Okay, so we've got a question here on series and parallel circuits. The first one is simply just asking us to identify what component we've got shown by this graph. There's three current potential difference graphs that you should be able to know and recognise. I will go through those in a second. The one that we've got here is a filament bulb. We know because as we increase the potential difference, the current is increasing still but at a decreasing rate, which means resistance is increasing, which is what happens in a filament bulb. The other two we should know are indeed diode, which we've got here as an option. We should know that current in a diode only flows in one direction, so we get a line that looks like this, where we've only got a line on one side of that graph. And the other one that we should know is a fixed resistor, and we should know that obeys Ohm's law, so it should be a straight line through the origin of that current potential difference graph. The next part of the question is asking us what is the potential difference across X. Now here we need to know our series and parallel circuit rules. So in a series circuit, the current is the same everywhere, and the potential difference is divided between components. In a parallel circuit, the current is divided between branches, and the PD is the same everywhere. If you can just remember one of those, so either for the series or for the parallel, then you can remember that the other one is the opposite. So here we've got a series circuit here, but that series circuit splits into a parallel circuit here. Okay? So what is the potential difference across X? Now this is a parallel circuit here, so according to our parallel circuit rules, the potential difference is the same everywhere. That means the potential difference across X here is going to be 6 volts, because we've got a potential difference of 6 volts across our power supply. Calculate the resistance of X. Now we've got two readings here, 3A and 2A. That means 3 amps and 2 amps, they are currents. So we've got a potential difference, we've got a current, so we can work out our resistance using the equation potential difference is current times resistance. We're going to rearrange that. We're looking for resistance, so it's potential difference divided by current. Sorry. It wants the resistance of X, this resistor here, so we're going to use this current, 2 amps. So we're going to say resistance is 6 divided by 2, which gives us 3 ohms. It's then asking for the current in Y. Now we know, according to our parallel circuit rules, that current is divided between branches. We've got 3 amps here, so that 3 amps must be divided between these two. 2 amps goes here, which means that 1 amp must therefore go there. 2 and 1 there gives us 3 there. So it's 1 amp. Then it's asking us to calculate the resistance of Y. Again, we're going to use this same equation, R equals V divided by I. We know that the potential difference across Y is 6 volts. And we know that the current is 1 amp, so it's 6 divided by 1, which is going to give us 6 ohms. And then the final question says, when the temperature of resistor X increases, its resistance increases. What would happen to the potential difference, the current and the total current in the circuit? Potential difference would stay the same. The current, if the resistance is increasing, the current is going to decrease, which means the total current in the circuit will also decrease.